Okay, so what do we got here? So let's move on to the last Git object we'll be dealing with in this challenge, the commit. You got the PDF, but not the zip archive password. Interesting. I've never done any password breaking. And while I can't recommend that anybody does that because there's obviously lots of issues with me recommending that, for anybody who has to do it for reasons of you losing your own password or anything else like that, it's certainly probably like a good skill set to like sort of play around with for if you need to break into your own things. Okay, let's move on to the last Git object we'll be dealing with in this challenge, the commit. And you have a reference to the git sem commit. To create a commit, you'll need the following information: the committer author's name plus email, the timestamp, the tree SHA, the parent commit SHA, if any. In this stage, you'll implement git commit tree. So a plumbing command that creates a commit. Your program will be invoked like this. Okay, so they'll run your git sh commit tree SHA. Okay, so they're gonna do a write tree, and then we hand it the tree SHA -p. So we have to look into commit tree what this is doing. Commit SHA, and then message. You'll receive exactly one parent commit and exactly one line in the message. You're free to hardcode any valid name email for the author committer fields. Okay, so we just create any valid. So we can just use Mailinator for this. Your program must create a commit object and print its 40-character SHA to standard out. To verify your changes, the tester will read the commit object from the Git directory. It'll use the git show command to do this. Okay. I don't know if learning all these other commands like git show and git like hash file is really interesting. All right, so I want to do let's look through these. So we have our commit objects. If you've done all of the above, you now have 3 trees that represent the different snapshots of your project that you want to track. But the earlier problem remains. You must remember all 3 SHA-1 values in order to recall the snapshots. You also don't have any information about who saved the snapshots when they were saved, or why they were saved. This is the basic information that the commit object stores for you. To create a commit object, you call commit tree and specify a single tree SHA-1 and which commit objects, if any, directly preceded it. Wait, was the other thing M? Was that what it was? And I was just like, oh, so we're gonna have tree SHA. P is the commit SHA. Oh, interesting. Okay. So if we do, oh, this takes in the message as standard in. Interesting. Start with the first tree you wrote. No, you'll get a different hash value because of different creation time and author data. Right, so every time you do this, it'll be different. Now you can look at your new commit object with git cat file. Interesting, okay. The format for a commit object is simple. It specifies the top level tree for the snapshot of the project. At that point, the parent commits, if any, the commit, okay. Now, if we go take a look at this, this is the commit tree command, and that is what we are implementing here, commit tree. Creates a new commit object based on the provided tree object and emits the new object, the new commit object ID and send it out. Okay, so then interesting. Having more than one parent makes the commit a merge between several lines in history. That's interesting. That's how it tracks merges between commits. Okay, so we have a parent, we have a message. And then, okay, so we have the tree. Interesting. Okay, so if we were to do, like, we have no changes in here right now. So if I wanted to make an update, so let's say oh, we already have a, okay, so we're gonna do, I did not need to exit out. I keep on doing that by accident. Okay. We created another little line at the end with the README. I don't know why I didn't see. The README is right there. It's just in yellow. For some reason, my brain completely ignored the yellow and looked only at the white, blue, and red. That's interesting. The way my brain was sort of like parsing through the colors there. I wonder if it's because it was exactly the same as this, and therefore my eyes were like, oh, that's the same as that, and just ignored it. Okay, so I want to do a git commit tree. No, so hold on. We need to do this separately, right? So in order to create a tree of that, I now need to do a get add. That's added. Now I can do a get write tree. That gives me that. Then I want to do a get commit tree. We give it the one parent, so -p. Is that right? No, the tree is that. Okay, hold on. Oh, it's the parent is a single commit SHA. Oh, it's like the previous commit that we had, right? What is it? Git log. So it would be this one, right? So we do git commit tree. Okay, so one parent. Oh, so we have our tree SHA. Okay, so you're actually going to be doing it. Okay, similar to this. So we have. Interesting that the order is different for these two. I wonder why that is. I wonder if they're trying to say that, like, the order doesn't really matter. Let me try it in the order that they're gonna give me. So we have the tree shaw first and then the commit. Okay. So that's the previous commit. The tree shaw is you. And then we're gonna have our -m message. So, and then our message is simply, does this work? Manual through Git. Okay. And if we look at our log, that doesn't show up in logs here. Okay. But we get this. So now can I do a git ls git cat file? No. Oh, it's supposed to do cat file -p, right? There it goes. Okay, cool. So that's what we're trying to create, is that. And if we go and look at objects here, so cd to git, or really we can do not showing in log because head is not pointed at commit. Oh, you're probably right. Because it's technically in the future as, because like when I normally do a git, it then also updates my head. So I have to check out that commit. .git, and I want to go to objects. So 4b, F6. Yeah, okay, so it creates that. So it puts it into objects, which makes sense. And then if I want to do our, what was it? It's pigs, that's what it was. Your 4b F6. Yeah, so what we expected, this starts with commit. So our header is commit space size null, and then tree. Parent, and then the rest of the author. Okay. So hold on. When we look at that, that's... Now, I don't think we have the tree, right? It starts with parent? No, it does. Okay, so when I cat file this, we have the tree here. On a new line. Interesting. So we have the tree. So not showing is commit size. That's it. Commit size null. And that is not a new line. Oh, so ls tree is writing it with new lines for us. Okay, good to know. Okay, so, oh yeah, P does pretty print. I keep on forgetting that P is for pretty print. So it is making it look nice for us. I don't believe we are pretty printing that. Can I cat file that? So can I do a cargo run cat file, pretty print. I want you. Yes, okay, so that oh, ours is actually doing the same thing too. I just forgot that we implemented pretty print exactly the way that they did it. Okay, so I feel like this shouldn't be that hard for us to do. Let's jump into it. Now this is commit file. Nope, not that. I wanted to go here like this. This is commit dash tree. Okay, there's a few things that we need to get out of here. So first we need to get, this is the tree, right? So we have the tree. So let's just clone it. Actually, I don't need to clone it, do I? Just make this that. That'll be fine. Okay, so we have our tree. And then we assume that you're a P. So we assume that you're now going to be the parent. So if args of 3 is not equal to dash P, we want to panic missing parent option argument. Okay, and then we're gonna do to make this a little bit nicer. What if we do something like this? Or let our parent equal to, if args of 3 is equal to P, okay, so in this case I want to return args of 4. Okay. You can't assume dash P first commit doesn't have a parent. Well, in a normal one, absolutely, you'd be right. In this case, your program will be invoked like this. So we know that they're always getting us a dash P. You'll receive exactly one parent commit and exactly one line in the message. So this is where it's like, okay, this is the I am matching what they're giving me, which is maybe not like it's not real worldy, if that makes sense. But it passes the test. Like if I was doing a real worldy, I would use the actual proper CLI handling tools to sort of like, okay, give me a dash P, give me all that stuff. If it's not dash, if that's not passed in, it's the first commit. Otherwise, yeah. Okay, and then we'll get the dash M for message. So this is gonna be 5. If that's equals dash M, we return args of 6. Else we're going to panic. Missing message. Okay, so we have you. So I should be able to, I guess we'll just debug you for right now. We have our tree, we have our parent, and we have our message. So I should be able to do a cargo run, commit tree, bunch of like a tree, a parent, and a message. Okay, so we grab those out. Excellent. Okay, so I need to add in a file for commit tree. Which is actually going to be under library. Okay. So we know we're going to take in the tree, which is going to be a stir, the parent, which we know is going to be a stir, and then a message, which we know is a stir. And we're going to return something, probably a result of some kind. We're going to use the anyhow result. It's probably going to be a string of some kind. So let's to do this. All right. So if we go back to you, we can run you. So we'll do let our, this is going to be the hash of, okay, so let the hash equals commit tree. Okay, so we have our tree, parent, message. And then we're just going to do a simple print line of the hash. Okay. Because that's, I forgot apparently how to do print line. That's what I want to do. Okay, so there we go with that. It's not what I want to do. I want to come back to, do I want to come back here? No. I'm gonna come back to here. All right, so we're calling this, and whatever we're printing back is fine. So what do we want to do? We want to, let's see. It's going to create a new file. It's going to create a commit file. It's going to add the header to that. So we're going to create the commit file. We're going to add header. We're going to get checksum. We're going to compress it. We're going to save it. And then we're going to return it. We're going to return a hash. That seems to be what we need, right? I think so. All right, so create the commit file. So we're gonna start with just a bunch of blank empty. Basically, it's just gonna be an empty vector, right? So we have our commit file, and this is really gonna be commit bytes. is you're going to be a empty vector, and we know you. You're going to be a vec of U8, and that's going to be fine. We're going to get to you in a little bit. If you have enough money to spend to be able to subscribe to someone, you'd be the first one. You do, however, oh please, yeah, don't subscribe if you don't have the money. I like they're just having you be here and like be part of it, be part of the community is more than enough. I don't ever want anybody to like subscribe or like pay me money if they can't afford it. I do see that a lot on Twitch and like other things, like, oh yeah, just like go ahead. It's not that much, which I don't know, it feels skeevy. I want people to succeed. I want you all to like, I want you to get to the point where you can, where you get all the money you need. Which usually means graduating from college if you're, or school, whatever school you're in, and then getting a job. That's usually what I want you all to be able to do. Okay, so we have our commit bytes. So that's our create commit file. Done. Now, commit header. I know you need that. We'll figure that out. Now the header is going to be that plus the size, right? So that's going to suck. So our header is going to be equal to us like the string, which is, so we're going to format this. You're going to be commit space and then size of some kind, and then a null. So we know that you exist. That means we need a size, and then right now that's just going to be 0, because you're starting with 0. And then our, oh, you know what? It's going to be the commit bytes length. So it's going to be commit bytes length, like that. Now, of course, you don't have any, so that's fine. So now to add the header onto this, we're going to then, I want to prepend, so we're going to do a commit bytes I guess like we want the end result, right? So there's extend, which adds at the beginning. This adds it to the end, right? Yeah, I want to do the opposite. I want to add it to beginning. I don't think that has something like that. Oh, wait, we could do the opposite. What if I then do our as bytes okay, so this is the commit. Okay, so this is the commit body equals that, and this is going to be the full commit plus the header. And then I want to now do commit as bytes into vector to vec. I now want to extend the commit body. Okay. You're now the commit body dot length. Okay, so there we go. That's good. Yeah, this will be fine. I'll just like get the commit body and then I extend the commit with the commit body. I think that works. Okay, so there we go with that. So now we've added the header. We have to get the checksum from this now. So, which we already have. So with the get hash, right? So letter hash equals get hash with a reference to the commit. And there, okay, so now we have the hash as evacuate. Okay, so now at that point we can return this, so we know that you're going to be an okay with the hash. What was it that I need to get that? You know, I don't think it was any of those things, right? It wasn't the permissions extended. It's not. I don't think it's any of those. In main, we're doing the, let's see, right tree. Oh, I'm just doing hex encode with that. Okay, fine. We'll just do hex. I thought there was a encode hex that we can grab in here. So like the hash dot and oh, there it is. Encode hex. So there we go. All right. Slowly bringing it together. Roshan, hey, amazing content. You follow the channel. Well, thank you very much. I'm glad that the content is helpful. There is into bytes on a string that directly gets you let's see, what was I doing wrong? It was as bytes to vector. Let's try that one. So this is into, you're right. One way to do it. Much better. Thank you for that, Albert. Okay, so we got you. Okay, so we got our hash now. We compress it. So let the compressed commit is now going to be okay. We compress you. We hand you the content. That's going to be our commit. Okay. Okay, so now we have our compressed commit. Now, at some point in time, we have to create and insert something. So in here, we have to put the commit into the body. It's kind of something that we need to do at some point in time. Because right now, there's an empty commit. It's not really helpful. Although I think that Rusty could have optimized the same. Oh, wait. You're like writing your comment across both systems. Yeah, well, I mean, I'm pretty sure that in the end, because like Rust, the Rust compiler is trying to be as fast as possible. It has that thing where it calls it zero cost abstractions. It's like, yeah, if I do a bunch of stuff that's unnecessary, if in the end it can become the same thing, the compiler will make it the same thing. And one of the reasons why the compiler is so much slower compared to many other languages, because it's doing all that stuff for us. Although the compiler is getting faster and faster with every update, which is really nice. Okay, so we have hashed. Okay, so we have our compressed commit. We need to save the file. So is there a save? save to disk, which takes in the compressed. Okay, so we have our compressed commit. And then we return the hash. So here, let's organize it that way. So the last thing that we need to do is just throw these things and throw the actual content into the compressed body. Now, if I run this right now, this should have a commit space 0 null in it and then nothing else. So I kind of want to test that. So this is going to be our commit body. So we want to do a cargo run commit tree. There, that should get written out to file. So I should be able to do a, what was it? Is the pig? Nope, nope. What did I do? There. This went into DC F5. Uh-oh, that did not go there. EE. No, that's not right. Did this not actually write out? It did not. Okay. Okay, so actually, now when I save the disk, wait a second. Save the disk. Oh, compresses it here. I don't need to compress it myself. Okay, so, all right, hold on. We don't need the hash there at all. Do let our hash is equal to save the disk, and then this is the commit. Like that. That's what I wanted to do. So I hashed the compressed ones. That's obviously a problem. Okay, so let's cargo run this again. And I want to do a nope. Oh, I don't need the helix right now. That's what I was doing. Okay, and then you are gonna be the DC F5. There we go. Yes. Okay, so that's exactly what we have. We have this commit 0 null, and that's it. So that's exactly what we wanted to see. Okay, so good to know. Now we put in then inside of you. Did you show this behind the scenes? Don't remember if it does. One of these things it kind of did, right? Commit objects. Yes. Okay. So once we have that header, then we're going to have tree space and then the tree. Okay. So then we want to, okay, put the commit into the body. So we want to add in the tree into here now. So that's going to be our commit body. We're going to extend, and it's going to be format the tree. What was it? It was the name tree space the hash, and then is there a null at the end of this? I don't remember. We looked at that beforehand. Okay, so here is TREE space 300 null, and then no, wait, this is not a commit. This is the wrong one. Oh, you know what? I don't think I looked at the object correctly. So let's do, can I go back until I find, those are called cargo runs. Oh, git commit tree. Oh, so you're this F3 3F. F3 3F. Uh-oh. That didn't work. Cat. Okay, so this is 4BF6. Okay, yeah, so commit. So COMMIT space 1 2 3 null TREE space the commit, which should be 20 of these, right? So what is it? TREE space so it's 8 16 4, and then that immediately goes into the next thing, 31, and then parent. Okay, so it's there's no nulls in here whatsoever. That's interesting. Okay, that's good to know. All right, so we just have tree like that, and we pass the tree, and then that's it, nothing else. So then I want to into bytes that, and then we're extending that. Are you okay with that? You are okay with that. Excellent. Okay, so we have our tree that we're adding in. Okay, so that's the first one, right? Now the second thing that we throw in here is the parent. So parent goes in next. We have parent. And that's going to be the parent like that. Why are you upset? Oh, because I can't extend it multiple times. Got it. Okay. There you go. So we extend, now we have the parent. I mean, there are some things that are more important than others, right? Like domain names, especially if they're useful to us in the future or now, especially for business purposes or something else, like I can see that those are much more valuable to spend money on. Like giving me money is like, yeah, sure, that's really nice and I appreciate it and it's like it's very welcome. But if you have something that's like really important to spend on, then domains to me like is that probably comes higher in a priority. The way I see that. And like courses that I can create would be important too, which is one of the reasons why I'm creating courses and doing all this stuff is like hopefully then there's value that you can get in exchange for money. I don't want it to always be one way. Okay. You think you spent less than 70 euro to get your domain name for 9 years? That's really good. Okay, so we have a parent. Next is we have author, and so we can lie about this. So we have our commit body. We extend. I'm gonna format. Okay, so this looks like author. So we have author, and then we can just make something up. So this is going to be Brooks. What's the way that they show that it looks like? It's author. What's that timestamp? Oh yeah, it includes like an actual timestamp. Author Brooks, and then we'll just say Brooks at melanator.com. We do need a timestamp, don't we? But we have access to time. So in here, right? Isn't there a time thing? Request bytes. Oh, for some reason I thought they were giving us a time library. But they did not. Okay, well that's fine. So I need to get like the timestamp, and then we'll just do minus 700, because I think that's what 0700 is. I think the that's the GMZ time zone. GMT. Okay, so if we do that, now we need the timestamp in here. Now, it's not a duration. I need like I need the now. I need like some time. There's a time module instant. Is there like an instant now system time? Maybe that. We could do system time. Now. Okay, you give me a system time, and then you're upset because why? System. Oh, a couple of reasons. So first, you need to be into bytes to do that. And then timestamp. Oh, ad break. Perfect. I need to take a really quick break, and I'm gonna go grab a snack because man, it's 1:30 already. Oh man. Okay. Yeah, I don't really care if it's real time or not. It just has to be a proximity of real time. All right, we're gonna do a really quick break. Nope, wrong break. I wanted cat break. And then I will be right back, and we'll continue working on this, and hopefully it should be good. So I will be back in a minute. Or 3. All right, let's see. Yeah, we do see the top of the green screen. Yeah, you do see there. It doesn't go quite up to the ceiling. So when we're in standing mode, I have to like have the camera pointing down a little bit. Let's see. Crazy Frog, hello. How are you doing today? How do I not want to blow my head off when trying to use async rest? I think, I mean, there's several different types of async rest, right? There's doing async with like creating all of the threads yourself manually. There is using async await with with something like Tokyo, and there is using async await, or yeah, I guess async await with anything that's not Tokyo. I would recommend staying with Tokyo. That has like the most support in like the most documentation right now of everything that I've seen. And after that, having ironically, having the same mental model as promises in JavaScript is probably the next easiest thing to deal with, which is not helpful for most people if you don't know JavaScript. But it's as long as you stick to trying to remember of like how that works, like how the JavaScript sort of mental model works with async code, it kind of just is exactly the same. Yeah, no, I mean, it's not great with promises in JavaScript, but the idea of you using like async await with that, where like, okay, my code is actually being wrapped in something that's running asynchronously, but the next line of code won't finish until it's going, but other code can sort of like go through and is simultaneously running, and it's all in this like weird event loop that's happening behind the scenes. That kind of just like, if you just take that mental model and like lay it on top of Rust with async await, it kind of just works. And it's shocking how well that works. Okay, so let's okay, so timestamp, you don't implement display. Now I'm curious, you do implement debug mode. Okay, so let's find out what exactly you are that you write down. So let's do Brooks, not real address. So if I do a cargo run, we commit tree for that. And then we want to do a cargo cat file. For you. Oh, it was cargo run. Okay, so tree. Oh, let's do a get. Tree size. Huh. Oh, it put in, oh, ew. Okay. Oh, we have TV nsec. Huh. Which one do I want to use? Let's see. Oh, what did I miss? Theodore Ellen, hello. How are you doing today? You're trying to inject stuff there. So chat doesn't run on my, I don't have a bot running all chat on my system. I would like ask that you don't just spam though, because that makes it so that other people's chat is less easy to read. And I would hope that Nightbot doesn't just run this. Also, I run Mac OS, not Windows. That's true. I do have Windows and Mac OS. I could be running chat on both. I'm not running chat at this time, although I do have other things happening. You're doing good. How about you? Yeah, I'm doing pretty good. It's a good Monday here. We're getting really decent progress on this project, which is also good. All right, thank you. I guess like it's more of like the fake hacking spam. Mostly because that could just take up a lot of lines. The every once in a while though is fine. And funny. Okay, so what did I do wrong here? Obviously system time. Now I don't really care about the time. So what if I just get this TV sec? Can I just get that and use that? Let's see, timestamp. So I want the timestamp. Ooh, duration since. No, I don't want the elapsed. Returns the amount of time from an earlier point of time. This function may fail. Okay, no, that I don't think that's helpful. I want like now in, I think it's the epoch. Can I get the TV sec? Is that? Okay, we're gonna go take a look at the documentation. Oh, it's not docs, it's like doc. Oh, right. Yeah. If it starts with if it's docs dot, then it's the crates documentations. If it's doc dot, it's the Rust documentation. I keep on forgetting that that's how you can sort of like see which one's which. All right. So we want in the module time. Oh, wait, constants. Unix. An anchor in time which can be used to create new system time instances or learn about where time. Okay, so. This constant is defined to be, okay, 1970. Okay, that's good to know. So then, oh, okay. So hold on. So system time duration sense. That's what it is. Okay, so our timestamp system time dot now duration sense, and this is called Unix epoch. Okay, that gives me a duration, and then I want, you don't have implement display, so I want, ooh, how do I, oh, as millis. I think that's what I want. Okay, much better. So tree, that doesn't seem right. I miss something weird here is happening. But then we have you. Okay, so that's good. So we have our tree. Author. And then, okay, then committer. I don't think I'm supposed to have new lines. But maybe I am. Maybe I'm supposed to have new lines. I could swear we looked at the one we put in there. I didn't see a new line in there, but maybe I am. Let's see. C finally has type inference? Wait, really? Doesn't C barely have types anyways? Oh, try with the Pigsy command? Yeah, let's try that. Right, I need an actual commit. If I do get cat file, yes, let's take a look at. Okay, so I did a git commit tree, and so that gave me. Then I think we looked at this, right? No, then we did -p with this. Okay, yes, this was a real commit. See, this one has the new lines there showing up. And if we use a this was 4B. Oh, yeah. So this was the one. I literally just push an up arrow. Okay, 4B F6. Okay, that's exactly what I want to see. So we have this commit. So COMMIT space 255 space null byte, and then our TREE space, and then we have the hash. So 8, 16, 20. And then we have our PR, like PA parent. Where's the space in here? There should be a 20, right? So, okay, here's the space between parent and then the next hash. And so I'm, oh, byte 038. Where is 038? Is that a new line? So it'd be after tree, right before parent. So this one, right? So we have, here's a space. So D N E R E A P. Oh, is this it? 0A is a new line? Oh, I didn't realize that. Okay, so, all right, so then we're supposed to put new line in here. So we put, okay, tree, parent, new line, new line. Okay, so we do that. Then let's go ahead and try this again. Cargo. We commit true with that. We do a git C5F1. Okay, so tree, our size. This is really, okay, this is wrong. Something's going wrong with my header. What's going on with this? Then we have our parent, okay. So tree. So it's literally tree. No, header. So we start with commit space size, and then our size is our commit body dot length. Oh, wait. I'm not starting with commit. Oh, wait. Commit's not there. Oh. Yeah, look at that. I'm starting with commit size 0. Oh, that's weird. Oh, it's delete. Right, it's delete. I keep on forgetting that's deleted by cat file. Okay, never mind. So then, okay, so you're right. That's probably fine. That's probably working just fine. So tree. Oh, well, in that case, this actually is fine because that's the hash that I have. I am missing the new line here. There you go. Tree that parent. Tree that. Oh, there is no parent. For some reason, I thought we put parent in there. Yeah, okay, wait, this is the first one. Is there another one? Oh, that's just how to run it. Hold on. Okay, let's do our get our commit tree of that one again. So I want to do a get cat file C871. Okay, so the okay, wait, oh, ambiguous. So we have C71 CD. Okay, it does have parent in here. Okay, so we do have parent, and then that, and then we have author timestamp -700 committer. Okay, then committer, and I want this in there. So if I just take you. And do bytes. Okay, we do this. Okay, so we're gonna have committer. This is gonna be let's actually make this book server here. So Brooks. Okay, not really email address. And then I want the same timestamp, I believe. So we want that. which then if I'm doing this twice here, let's just do timestamp as millis straight from here. So then we just do timestamp timestamp. Okay. We have a space, -700, new line. Okay. We're good to go there. So now we've added in the committer. Let's see. Yes, man. Hello. Will I open source this project? Yes. I keep on forgetting to put this code onto GitHub because I'm just directly doing it off of CodeCrafters. I wouldn't like I don't have any like sort of teaching stuff in here, but yeah, I'll let me just write in what to do for that because I keep on forgetting to. So let's export CodeCrafters git code to GitHub. There is a way to do that. So CodeCrafters here has a publish to GitHub. So you can publish your code to GitHub. It just needs access to my GitHub. I need to like install something to like make it work. So I want to do it like their official way for that. So that's I'll eventually get to that. Rugmat, hello. How are you doing today? Yes, we're going to put real values in there. Absolutely. We're going to put real values in there. Let's see. I should probably do that now. So let's go ahead because now we know what a tree, we have the tree, we have the parent and all that stuff. We're good to go. Okay. So first of all, let's see, we get that. Oh, and then we have the message too. We have the committer. Okay, new line, a new line, and then the message. So I want to, after you, we have new line, then another new line, and then the message. So commit body, we're going to extend the message into bytes. As bytes? Okay. So we go with that, and then okay, that should be it, right? Then I need to do this with actual real stuff. So we want to do okay, so for the tree. First of all, get status. Let's get, I can write the tree right now and everything should just be fine, right? So we want to do get a cargo run write tree. And that gives me this. So we're going to do a, oh, and then I also need to get the most recent git commit hash. That's going to be interesting. So I want to do a cargo git log to get, this is the most recent hash. So we're going to do a cargo run commit tree. So, okay, for our parent, we're going to use you. And for our tree, we're going to use you. And for our message, we're going to say, hello from the chat. Okay, and that gives you there. And so now if I do a git, I could just use cargo run cat file p, and then we hand in this entire thing. There we go. So we have our tree, 10 bad, is that what it's supposed to have? Yeah, that was actually what it was. Oh, fun. Parent, author, committer, hello from Twitch chat. Okay, that looks right. Okay, so the question is, okay, now when I run this, okay, yeah, that did the thing. So hold on, what am I looking for? You're free to hard code anything. Program must create to verify your changes. The test will read the commit object directly from the Git directory. It'll use the git show command. Do this. Oh, they're going to use the git show command. All right, git show. What is that? Git show. Do I just give it the hash? This? Git show you? Ooh, okay. Commit that. Author. There. Hello. Git diff. Okay. Okay. Hey, that's not bad. It looks like a real commit. So let's go ahead and submit this and see if it works. We're gonna do let's see. Ooh, okay, so hold on. It's very upset with all this stuff. So I'm gonna create a new commit. I'm gonna use the normal method to do the git commit. So git add everything. We're gonna commit this with working. And we're gonna push you, and we're gonna see whether or not we get to pass this first try. Oh, I do have warnings there. That's not great. Okay, expected Humpty Monkey, Doobie Monkey, Horsey Monkey, new line as commit message. Got Humpty Monkey, Doobie Monkey, Horsey Monkey. Oh, it wanted this new line. I missed the new line. Okay, that's the only thing. We can get rid of some of the new messages too. So here we have a message as bytes. So I need to format you. Let's see, do into byte. We have our message. New line. Okay, so there we work with that. Let's also get rid of some of these unused imports. Okay. Let's see, added new line to message. We're gonna push that up and we're gonna see if this works. Try to. There we go. Excellent. Okay, so, well, that was pretty fast. And that's it. We are past stage 6. We have now created a commit successfully.